So look at the problem. It's another Main's 2021 problem from differentiation. See, given f is a twice differentiable function from 0 infinity to 0 infinity, and this relation is given as f of x plus 1 is equals to x into f of x. That's one relation. And the other relation is this: g of x is equals to logarithm of f of x to the base e. From there we need to calculate this value. Difference between z double dash of 5 and z double dash of 1 and its absolute values, its modulus is included. So how to answer this? First of all, we need to use this f relation and we need to make a relation in terms of g and differentiate g for 2 times to get g double dash. Finally, z double dash of 5 minus g double dash of 1 and its modulus is our answer. Okay, right. Look at the problem. Since f of x plus 1 is equals to x into f of x is given, right? And g of x is logarithm of f of x, right? So you apply logarithm everywhere. So then it becomes logarithm of f of x plus 1 to the base e is equals to log x to the base e plus logarithm of f of x to the base e. Okay, f of x plus 1 is x into f of x. Just apply log. Logarithm of f of x plus 1 is equals to log x plus log f of x. Now it is very clear that this logarithm of f of x plus 1 is nothing but g of x plus 1. What you say? Is equals to log x to the base e plus g of x. Is it clear? Given that g of x is log f of x, if g of y log f of y, but here we have g of x plus 1 which is logarithm of f of x plus 1. So now we have a relation in terms of g. Send this g this side. So we have finally g of x plus 1 minus g of x is equals to log x to the base e. But our task is to find second derivative relation. Okay, g of x plus 1 minus g of x is log x. Differentiate it one time everywhere. So g dash of x plus 1 minus z dash of x is equals to derivative of log x is 1 by x. Is it clear? Z dash of x plus 1 minus g dash of x is 1 by x. Differentiate one more time. Then it becomes z double dash of x plus 1 minus z double dash of x is equals to derivative of this 1 by x is minus 1 by x square. And now concentrate on this relation. Okay, what it is? Z double dash of x plus 1 minus z double dash of x is equals to minus 1 by x square. Okay, so this is the relation between g of x plus 1 and g of x. Okay, if you differentiate this, we will get this. One more time, if you differentiate, we have this relation z double dash of x plus 1 minus z double dash of x is minus 1 by x square. Our task is to find z double dash of 5 minus g double dash of 1. To reach there, replace x with 1 here. Concentrate on this relation, replace x with 1. If you replace x with 1, you will get z double dash of 2 minus z double dash of 1 is equals to minus 1 by 1 square, since we are replacing x with 1. After that, replace x with 2. If you replace x with 2, z double dash of 3 minus z double dash of 2 is equals to minus 1 by 2 square. One more time, replace x with 3. If you replace x with 3, you have z double dash of 4 minus z double dash of 3 is equals to minus 1 by 3 square. Now replace x with 4 here. In this relation, everywhere replace x with 4. You have z double dash of 4 plus 1, which is 5, minus z double dash of x, that means 4, is equals to minus 1 by 4 square. At the end, to find this, add everything. Add all these 4 relations. If you add, these 2 gets cancelled, these 2 gets cancelled, these 2 gets cancelled. We left with z double dash of 5 minus z double dash of 1. If you add all those values, and this is minus 205 by, see, you add all those values, you will get certain value, minus 205 by something, I think 144, I think so. Since modulus of g double dash of 5 minus g double dash of 1 is required to find, that means modulus value, modulus of z double dash of 5 minus g double dash of 1 is that 205 by 144. That's the answer finally. Okay, have a look.